Hey good humans, welcome back. Today I am going to talk about dilation. It is also known as scale drawing. Dilation is a transformation, but it is not a rigid motion. Rigid motions are rotation, translation, and reflection. Now dilation will not change the shape of the figure. The only thing that will change is the size. It will either get larger or it can shrink and get smaller. Okay? Now, there is always the scale factor that is associated with dilation. Now, scale factor is usually written as lowercase r. That is a symbol. And when they write the r, if they say to you the scale factor r is equals to 1, that means that the figure is the same. It does not change. Okay? Scale factor of r greater than 1, the figure gets larger. Alright? And the scale factor of r less than 1, the figure gets smaller. So you need to know those things. Alright? Now, usually they give you a figure and ask you to dilate the figure, or they also give you a figure and a center of rotation, and from that center of rotation you are going to dilate that figure. All right, remember now, with dilation the shape is being preserved but not the size. All right, so let's dilate this figure, and I'm going to do r equals 2. All right, r equals 2 for this. The first thing that you have to do here is that you have to extend your segment. And I'm going to extend my segment here. All right, extend your line. And you also extend in this line. Okay. And the next thing that you're going to do now is let's go and get this figure to be bigger than what it is. R equals 2. So because r equals 2, I'm going to place my pointer at y. I'm going to extend my pencil to x right about here. You can draw an arc if you want. Slide it up, the pointer up to there, and swing another arc. I am going to measure YZ. All right. I have my point here. Going to slide up to Z, and I'm going to place an arc there. All right, and then I am going to measure. Actually, not going to measure. I'm going to label. So this is now going to be my X prime and my Z prime, because this is Y. And then I'm simply going to connect my points. Okay, that is your figure. It's now larger. Okay, now what if they say to you, okay, I want this figure to be r is, let's say, greater than 1, r is 3. Okay, if r is 3, look what I'm going to do. Same procedure as I did before. You place a pointer here, you grab the measurement of xy. You mark an arc here, then you go to the arc and you mark a second arc. So you have 2 arcs from your endpoint here, okay? And then you do the same thing for the other segment. I go to YZ. I get my Z, I place my pointer here. I need my next arc right there. And what I need to do now, I don't need the other one. I don't need this. Because remember now I'm doing r equals 3. So I'm going to label this as X prime and Z prime. Okay? And I need to, let's see. Okay, and this is what my figure is going to look like. So my X prime, Y, Z prime is going to be now my image, and my pre-image is X, Y, Z as my pre-image. Okay, so pre-image is before it's been dilated, and after it has been dilated, it's going to be the image of the figure. All right, figure is now larger, but they might give you a center O and ask you to dilate that figure from the center O, either make it larger or make it smaller. So I'm going to demonstrate for you what is going to happen if I'm given a center O and I need to do so. All right, so I'm going to get rid of this. I'm going to keep my figure right there, my triangle, and I'm simply going to do my create my center O. So this, let's say this is my center O. Okay, so that's my center O. What I need to do with my center O, I am going to draw from center O a line going through each of the vertices of the triangle. All right, each of the vertices of the triangle from my center O. All right, let's go to the next one. And so we are still going to use our compass and create the arc that we need. So I'm going to place my pointer at O. I'm going to extend it to X, get my measurement, move it up, and I'm going to swing an arc here. I'm going to place my pointer at O. I'm going to get my measurement for OY, move my pointer up to Y, and I'm going to swing an arc. I'm going to come back to my center O, grab my measurement for OZ, and I'm going to slide it up here and get that. Okay, so I have that. All I need to do now is that I need to connect my points. So I'm going to label this as X prime, Y prime, and Z prime. So I am going to connect these. All right, connect this one. And then I am going to connect my last segment, which is X prime, Z prime. And voila! That's the image after I've just dilated from center O. Okay, it's fine. I've just done a dilation where R is greater than 1. So the image obviously has gotten larger. All right, it was enlarged, but I might say, hey, I want it to be R less than 1. What's going to happen if R is less than 1? Let's get into it. So R less than 1, I'm going to choose a half. Okay, I'm going to choose a half. I'm going to use the same triangle too, but I'm not going to make it prime. All right, I'm not going to make it prime. I'm going to get rid of these lines. And I'm going to show you what's going to happen. I'm actually going to make them a different letter of the alphabet. You don't have to always use A, B, C or X, Y, Z. All right, just want you to know that. Okay. So I have this and I want to do R equals a half. Yeah, R equals a half. So in order to get R equals a half, let's label my triangle A, B, C. I need to find the midpoint of 2 of the segments. I just need 2 of the segments of the triangle. I don't need all 3, but I'm going to do it on all three and show you why, but you'll see it. So let's go ahead and find the midpoint, meaning the halfway, because you know the midpoint of something is cutting that segment in half, doing the midpoint. So for me to do the midpoint of, say, segment AB, I need to do a perpendicular bisector. And if you had watched my previous videos on doing perpendicular bisector, we just need a little bit more than half the measurement of the segment. I'm doing the segment AB now, and I just need a little bit more than half the segment of AB. All right, assuming an arc, I'm going to place my pointer at A, and I just need the intersection of the arcs. I don't need to do the entire circle or semicircle. And what I need now, I just simply need the midpoint on segment AB. So I am connecting my arcs here, and I just need that midpoint right here. That's all I need. Okay? So that's my midpoint. Now I need to do the same thing for the other segment, for AC. So I'm going to do the perpendicular bisector of AC, place my pointer at C. I need a little bit more than half. So I am going to swing like this. All right, a little bit more than half. Okay, and then I'm going to move this over to A. As I said, I just need the intersection of the two arcs. Once I have that, then I know what I'm working with. So I need to connect this intersection of the arcs there with the other one, and I mark it on that segment AC. That's my midpoint. So now I can simply go ahead and do this. Connect both points, both midpoints. All right, connect both midpoints like that. Once I connect both midpoints, I can shape this out. Okay, I will now label this as B prime and this as C prime. And that's your half of your triangle. Okay, but what if you didn't do the perpendicular bisector of the segment AB and AC? What if you've done BC? Let's get into it. Let's see what happens. Okay, let's get into it. So I'm going to find the midpoint of BC. All I know, I need a little bit more than half. So I'm going to do an arc here. I'm going to go over to this side, right here. All right, that's all I need. And I am going to connect those, mark my midpoint there. Okay. So I need to mark this on this segment. That is my midpoint. And what I need to do now, all I need to do is simply do a connection between these two midpoints. I can connect these two. All right, I can connect these two like this. But in doing so, I'm going to now not label this as B prime. It's now going to be A prime. So I'm going to put slash A prime here. From this segment, it's going to be A prime, and then this is going to be C prime. All right. So just want you to be aware of that, and you can do this for your section. All right, your portion. So this is your half of the triangle. Okay, so you can either use this portion or this portion, depending on which of the two segments that you did the perpendicular bisector on. And obviously you can create a third piece. And the third piece here is just simply connecting these two midpoints to this one. And obviously, because this is C, you would now have this as not C, but B prime, and then this would be A prime. So you just have to be careful there which section you are working with or which portion you are working with, okay? Now, that is for R equals a half. Okay, R equals a half. Let's give you another one. What if it's r equals a quarter? Where do I go from here? Guess what? I'm here to tell you that all you have to do is also do another perpendicular bisector of segment A and B prime here. So I'm going to do it for you. I'm demonstrating it for you. So I need a perpendicular bisector. Watch where the lines are. Place your pointer here. All right. And I'm going to do this. And I'm going to swing down here. All right. And I'm going to mark where that is. And I want to mark it off as using these two. Right here is going to be on here. That's your midpoint. All right, that's your midpoint. And the next thing that you're going to do, you're going to do the perpendicular bisector of segment A, C prime. All right, and place a pointer at C, a little bit more than half. All right, a little bit more than half. And move over to A. All right. Remember now, you have to remember which arcs to use, so be very careful there in remembering which arc to use. So this is the arc here and this arc. So these two intersecting arcs, and you put your mark on A, C prime. Now, after you've done so, you can go ahead and connect those two midpoints. This is here, so this is now going to be B prime. For arguments, it would be B prime if you're doing a quarter, but for argument's sake, I don't want to mix up with B prime here. I'm doing B double prime here, but it would be B prime if you're just noting the one area. All right, and you have this. This would be your C prime. All right, let's call it just B prime. And then you would just shade off this portion as your R equals a quarter. All right, this is your R equals a quarter here. And obviously, if you had used this portion as your R equals a half, or you want to do it, you would do the perpendicular bisector on B and A prime here, and also on B and C prime right there to get your half and connect your midpoints accordingly. Okay, so that is what I basically have for you for dilation. Remember, the shape did not change, only the size. Okay, so be mindful of that. All right, that's the difference also between dilation and the rigid motions. Rigid motions, we know that the angles are being preserved and the segments are being preserved. Here, the shape does not change. It's only the size of the segments are being changed. Okay? And this is a transformation. It is not a rigid motion. So go ahead, hit that subscribe button. Tell your friends, share it, and like it, and let everyone be knowledgeable on dilation in geometry and ace that exam, or just know your fun facts. Okay? Thank you for watching, and please come again. Bye now.